All right, welcome to week 12. We're going to go over the third shape in our conic sections, which is hyperbolas. Hyperbolas are probably the funkiest ones, right? We have circle, ellipse, hyperbola, and then we're going to end with parabola. Hyperbola is going to be the weirdest. So we can see here that it has two parabola type curves. We're not going to call them parabolas though, but they kind of look like it, right? And that's the shape that we're going to learn how to draw, kind of like an hourglass shape or a bow tie shape. All right. So if we go into our notes, into our definition of a hyperbola, and I haven't really been stressing the geometric definitions, but we need to understand the difference between them. So our definition of a hyperbola is the set of all points in a plane such that the absolute value of the difference of the distances from any point on the parabola to any two given points in a plane, which are called the foci, is constant. So what that means, right? Here's those two curves that we said make up the hyperbola. Right, the hyperbola is both of those curves. What this is saying is if we take this point on the hyperbola and we figure out this distance, let's just say for the sake of this, that looks maybe 4. That's to one focus. And then we figure out the distance to the other one, let's say that's 7. So we do the absolute value of the distances. So we get the absolute value of -3, which is 3. That means if we now find, here's a second point, just random, and we find these distances, let's say this is 7, and this is 10. Again, we do the absolute value of 10 minus 7. The absolute value of 3 is 3. And they match, right? That's how we can form the shape. I will post a video that I found online from somebody else that draws this with string and stuff, so you can kind of see what's happening. But that's the definition of a hyperbola, that we have all of the points that meet that criteria, that if we take the distance between the point and the two foci, subtract them and find the absolute value, that it's just that arbitrary number 3 for everything, no matter where we are on the hyperbola. Other parts of this hyperbola, let's move on to the more cleared out side. Right, so here we have, it's not on here, but let's say we have focus number 1, focus number 2. We will call this point in the middle our center. All right, and we have kind of like how we had the major and minor axis in the ellipse, we have two axes of symmetry in the hyperbola. Our first axis of symmetry, we're going to call it the transverse axis of symmetry. And that word transverse, we've seen it before. It kind of means between, or, like traveling. It goes between the two foci. The other axis here is vertical, won't always be vertical. Here we're going to call that the conjugate axis of symmetry. It does not go through the foci, it goes through the void. That emptiness on the inside, okay? So let's fill that out in our notes. We said there's two axes of symmetry. The transverse axis, because it travels through the two foci, and then the conjugate axis, which is perpendicular to the transverse. or through the void. All right, we have a couple more words. Where the two axes meet, that's called the center. All right, and then the location where the transverse axis of symmetry intersects the hyperbola, that's called a vertex. All right, so if we look in at this one right here, here would be vertex number 1, and here would be vertex number 2. Kind of looks like a parabola, right, with a vertex at the very most bottom point. And then we will have some asymptotes in this graph. All right, so let's see how we're actually going to start graphing this. And it's not actually too terrible as long as we know the steps. And there's 5 steps, all right? So the actual equation for a hyperbola, when we look at our cheat sheet, which I'm not going to flip to because I know I'll get sick if I keep seeing all these screens fly by. We have 2 standard forms, or vertex forms. I go back and forth between those words. We have one where we have x minus h squared over a squared, right? So it's looking like an ellipse is equal to 1. We have where we have addition in between, but we have a negative in front of the x fraction. Or we can have that switched where we have x minus h squared over a squared, and then we have the minus in front of the y piece. And this creates 2 separate hyperbolas. The first one, if the negative is in front of the x and the positive is in front of the y, it's going to be opening up and down in the y direction. If the positive is in front of the x and the negative is in front of the y, then it's going to be opening up and down in the x direction, right? That's, again, in your cheat sheet, the last page of this document. It says if the negative is in front of the x, then it opens up and down. If the negative is in front of the y, then it opens right and left and has all of the ways to help you out. Here, if we look at this, I'm not sure why this is here. This is not supposed to be here. We have the negative in front of the y. So if we check our notes, that means it's going to open up and down, but we still need to figure out all this other information. But we can at least figure out what h and k are, right? And that still forms like it did in the circle and in the ellipse that will form the center. And then we also need to figure out what a is and b is, and we're going to use that for a lot of our other stuff. So let's start off with our center, because it's always the most important. That's the starting place for everything. That's step 1, is figure out where the center is. So we still have, like we did in the circle and the ellipse, we have x minus h and y minus k. So here, because we have the minus already there, h is positive 3. And then because we have the positive here, we have to switch the sign. So that means k is negative 5. So when we draw the center, we go 3 over and 5 down. Right, that's the center. The next piece is going to be what I just referred to as the box. And we use a and b to do that. So kind of like how we had those inverse trig functions where it was built on top of the regular trig functions, we can kind of see this hyperbola of being built off of the ellipse. So just like an ellipse, we have this fraction where we have a squared on the bottom, so that means a is 2. And we have b squared on the bottom, so b is 3. And those numbers still do the same thing for us in a hyperbola. So a is connected to x, so that means we go 2 in the x direction to the right and 2 in the other x direction to the left. All right. And then b is underneath y, so it tells us to move that spaces from the center in the y direction. So that's up 1, 2, 3, and down 1, 2, 3. And this forms again, has no really technical word. But I will just call it the box. So we said step 1 is to find the center. Step 2 is to draw the box using A and B. Next up, and we can kind of see that, right? So here's a box, right? Here's a box. We can kind of see it. Next up is to draw those asymptotes. So we didn't see them yet in those first 2 pictures of a hyperbola, but we can kind of see them even though we didn't have them drawn. So it kind of looks like, right, we have this X, but the pieces just don't touch in the center. And if we zoomed out more, it would look more like this. But we can see the asymptotes once I start drawing them in, right? So let's draw that next. So step 3, draw the asymptotes by connecting opposite corners of the box. All right, I'm going to do this as dotted lines as we usually do with asymptotes. So I'm trying to be very careful so that way our hyperbola looks very good. All right, so there's one asymptote. All right, there's our second asymptote. So now, step 4 is going to be actually drawing our hyperbola. So first thing we do is we need to decide which way it opens. We said we have the negative in front of the y, which I don't know why I said up and down, that's not right. If it's negative in front of the y, we said, and it says in our cheat sheet that it's going to open up left and right. The way that I think about that, it's not really where the negative is, it's where that invisible positive is. So that positive is in front of the x, so it opens up in the x direction. So that means we're going to have 2 C's, right? Those 2 curves opening up in between our asymptotes. And that box is the center, that center emptiness between the 2 curves. So what we can do is draw where the hyperbola curves get as close to the center as possible. And that's right on the edge of the box, right? And we said, right, this distance right here, we counted A apart. All right, and that's going to be important once we get to another type of problem. And then what we do is we start going down the asymptote, and then we curve down to the vertex, and then we curve back to the asymptote. So that way we open left, and we do the same thing on the right side. We can start at the vertex, and then curve to the asymptote to try to form those 2 C's. Right, so step 4 was draw hyperbola starting at vertex, vertices, and approaching asymptotes. And then lastly, step 5, and this is probably going to be the trickiest part because it involves doing some square roots and stuff like that, is going to be to find our foci. All right, so step 5, we're actually going to come all the way over here to some empty space. Step 5 is calculate and draw foci. And I'm going to actually switch to different colors so we can keep this stuff all separate. So that one is the bit trickiest one of them all. The foci are those 2 given points in our definition. And they have a very mathematical root. We could talk about the proofs, but I think it'll just be easier to talk about how to find it. So just like with an ellipse, we're going to have some squaring going on, and lucky enough for us, this is exactly the Pythagorean theorem. So we have c squared, and it's kind of rearranged for us. C squared is equal to a squared plus b squared. So here that means we have 2 squared plus 3 squared. So that means we have 4 plus 9. So we have 13. Which means we want the square root of 13, which we can approximate so that way we can graph it a lot easier. So in our calculator, we would get 13 square root 3.661. And that means because we're opening up left and right, we're also going to go left and right for our foci. So we count 1, 2, 3.61. That's one of our focuses, our foci. From the center, 1, 2, 3.61. That's our second focus. And if we need to, we can actually figure out the coordinates of that by doing, and again, it's in our cheat sheet. We would do the center in the x value plus and minus the c. So here we had positive 3 plus 3.61. So that's 6.61. We didn't change the y, so that stayed at negative 5. And then over here we did 3 minus 3.61, so that's negative 0.61 and still negative 5 as this focus. All right, so that's all the steps. Graph the center, draw that box using A and B, connect the corners of the box to draw our asymptote. Step 4 is to draw the hyperbola, being careful of which way it opens because of where the positive and the negative are. Drawing it so that it touches the box, but also touches the asymptotes. And then step 5 is the most difficult because you have to use the Pythagorean theorem, is to find the two foci. So, I want to go over another example with you, but I'm going to actually stop the video here. And then go over some more examples. I don't want to do example B here because that involves a little bit more work. Let's go to this one. I'll do it inside here. So we have some more examples. So let's do 9 and 10 as some examples. Here we know we have a hyperbola. Number 1, we have it equal to 1, and we have this subtract sign, right? If it had a plus sign, it would be an ellipse or a circle. But because we have that minus sign, right away we know it's a hyperbola. So from this information, just from the way the equation looks, we can figure out what h and k is for our center, and we can find out a and b. So to find our center, we have to switch the sign inside. Be careful here because x is on the side that we're not used to, right? We need to be careful. So here, h is, right, then we switch the sign, so positive 1. K is positive 2. A, we take the square root. That's not A. A is always underneath x, so we take the square root, that's 2. And then for B, that's underneath y, so we take the square root of 1, which is 1. So we can start graphing almost most of our hyperbola right away with just that information. First, we graph the center. So 1, 2, that's the center. Step 2 is graph the box. So we use our A and B. So A is left and right. So we go 1, 2 to the right, 1, 2 to the left. And then our B is up and down. So we go 1 up and 1 down. So here's our box. And this is where the hyperbola is never going to go in. All right. And then we can draw our asymptotes. That's step 3. All right, being careful to try to make it as perfect as possible so it goes through the center and through the corners of the box. All right, so we have our asymptotes. Step 4 is to draw our hyperbola, and we need to be careful about which way the hyperbola opens. So here we have our minus sign in front of the x, which means our plus sign is in front of the y. And we can either remember it either way or use our cheat sheet and just look at where it is. But we have If it's in front of, if our positive sign's in front of our y, that means it opens up in the y direction. So we're going to have one that opens up and down. All right, so that means it's going to touch the box right above and below the center, and it's going to hug those asymptotes. So we can try to do our best to draw it. Come down on the asymptote, go through a vertex, and then come back up. All right, these are going to be very shallow looking hyperbola. Asymptote, vertex, back to asymptote. All right, so that's our hyperbola. Those are the actual curves of it, right? The hourglass shape, or here it looks more like a bow tie, right? And then lastly, we need to find our foci. All right, here because it's opening up and down, the foci are going to be above and below somewhere, but we need to figure out where. And this is the trickiest part, right? Part 5 is using that c squared is equal to, and then lucky enough for us, it's just Pythagorean theorem. So we need to, it doesn't really matter which direction it opens up in, we still use the same one for either case. So here we have c squared is equal to, and then we have a squared, which is 4, plus b squared, which was 1. C squared is equal to 5. So c is equal to the square root of 5, which according to our calculator, that's approximately equal to 2.24. So again, because it's opening up and down, we count up and down from the center. 1, 2, 2.4. All right, and we went up from the center. The center was at 1, 2. So that means this is at 1, 4.24. And then we count down from the center, 1 to 2.24. So that means this is at 1, negative 0.24. All right, so that's again, step 1, we figured out the center. Step 2, we drew our box using A and B. Step 3, we connected the opposite corners of the box to draw our asymptotes. Step 4, we drew our hyperbola curves by being careful about which way it opened and connecting the vertices on the box to the asymptotes. And then we did our math to actually figure out where the foci were. So let's try to do another one. Trying to decide which one's more interesting, 10 or 8. I think 10 is. All right. So here, we might be confused about why these two are the same number. But we really don't care about that because we know this is for sure going to be hyperbola because of this negative sign. All right, so again, right away, because we see that negative and one fraction is positive, one fraction is negative, we know it's a hyperbola right away. So we can start graphing this by figuring out, and hopefully you know the steps by now. Step 1 is the center. So we look at inside the parentheses to find our h and k. So we always look next to x for our h. It's a negative 3, so that means positive 3, right, because we switched the sign. For our k, we look next to the y. It's a positive 2, but we switched the sign. So we get 3, negative 2 as our center. Step 2 is to draw the box, right? But we need a and b for that. So a is always underneath x, and we take the square root to find a. So a is 2. And b is always underneath y, so we take the square root and we get 2 as well. So to draw our box, here's a square. Because a is 2, we go 1, 2 to the right, 2 to the left. Because b is 2, we go 2 up, 2 down, and then we just draw that box. Right? Step 3 is draw asymptotes using the box. So again, we're being careful here to connect those corners through the center, extend it as far as we can. All right. Step 4 is to actually draw the hyperbola. So here you actually need to figure out which way it opens. We have our positive in front of our y. We have our negative in front of our x. So that means it's going to be opening in the y direction because the y has the positive. So it's going to be opening up and down. So our two vertices, our vertices are above and below the center. And then again, we start on the asymptote, go to the vertex, go back to the asymptote, or we can do vice versa. Start at the vertex and try to curve out to the asymptote. So we have our two curves. Last step is to find, we'll calculate and draw the foci. All right. So that's going to be c squared is equal to a squared plus b squared. So c squared, and we can be lazy and just take a squared and b squared, right? Get c squared is equal to 8. So c is the square root of 8, which is going to be approximately, all right, 2.83. So again, we start at the center, we go up 2.83, down 2.83. We can figure out the foci, which is one of your Khan Academies, by actually adding and subtracting that from our center. So our center was at 3, -2. So if we add 2.83 to our center in the up direction, that means we're adding it to y. So we get 0.83. And if we go down, that means we're subtracting it to the y. So we get 3 -4.83. All right. On Khan Academy, it might ask for your answers to be exact, which this case we would get 3 -2 plus square root 8. Down here, we would have 3 -2 minus square root 8. So we can just keep it in that radical form like we have right here. All right. So that's how we graph our hyperbolas. The next video, we're going to go over how to find the equation of our hyperbolas. All right. See you then.